You can start whenever you want.
Okay. Hello everyone, I'm Satvik Ram, a PhD student in Computer Science Department at Stony Brook University. Today I will be presenting our paper titled Enabling Uniform Computer Interaction Experience for Blind Users to Large Language Models. In this paper, we present a new assistive technology that enables blind people to easily and uniformly interact with computer software applications. To set the stage, let's examine the current challenges that blind users encounter when using technology. As we all know, blind users predominantly rely on screen readers to interact with computer applications. A screen reader is a sophisticated software that converts textual content and diverse interface elements into speech. It also facilitates content navigation through an assortment of keyboard shortcuts. Nevertheless, this navigation remains mostly one-dimensional, and most of these shortcuts are very complex, making them burdensome for blind users to remember. For example, as illustrated in the slide figure, in Word application, to interact with the normal drop-down option under the margin sections of the layout tab, users must press Ctrl Option Shift down arrow. So therefore, efficient navigation with screen reader requires memorization of numerous shortcuts and navigation strategies, given that most application GUIs are primarily designed for sighted two-dimensional point-and-click interaction. The heterogeneity of the application's graphical user interfaces further increases the interaction burden on blind screen reader users. So specifically, different applications have different interface layouts. Consequently, blind users must memorize different application-specific shortcuts and navigation strategies to efficiently access content in applications. So, even accessing the same application in two different platforms requires memorizing different sets of shortcuts. So, as illustrated in the slide figure, accessing the font dialog box on Word interface requires pressing Ctrl Shift F on Windows. Conversely, on Mac, the equivalent action is Command D. So this heterogeneity in access across applications and platforms has been shown to have significant negative impact on blind users' experience. For instance, in various computing tasks, studies have shown that blind users are up to 10 times slower in worst case scenarios, so they often experience cognitive load, overwhelm, and frequently struggle to recall the precise shortcut for specific tasks within applications, leading to unintended keystrokes. To address these challenges of blind screen reader users, we introduced Savant, an easy-to-use assistive technology that facilitates a uniform and efficient interaction across applications. Interaction using Savant is very simple. The user only needs to press a shortcut and give a natural language command. Savant automates the screen reader task specified in the command by determining the sequence of steps needed using an LLM. For example, as shown in the figure, in Word application, the user can say, set the margin to narrow, and Savant will automatically execute the corresponding sequence of actions to fulfill the user request. So this way, the user is completely shielded from all the intricacies of the application's graphical user interface. Before developing the Savant, we conducted a Vidodaffa study to understand the types of natural language commands that Savant might receive from the blind users. In this study, 11 blind participants were asked to perform various tasks across 5 applications, namely Excel, Gmail, File Explorer, Word, and Zoom. The goal was to simulate real-world scenarios and observe the kinds of instructions users naturally give. Each command was meticulously annotated with a control value pair specific to the application, creating a data set of total 145 natural language commands. For example, if a participant said, set the font size to 14 in Word application, the control element CE is font size here, and the value of CE is 40. So this data set serves as the essential seed data for training and testing our interaction model, supporting Savant's ability to respond accurately to user commands. The core of the Savant is a large language model that accurately maps user commands to corresponding sequences of screen reader actions on applications GUIs. We specifically use a few short prompting strategy to guide the large language model to generate accurate action sequence for input commands. Therefore, as shown in the figure, as a pre-processing step, we first created a few short example dataset by crawling a diverse set of applications, extracting their full layout information in the form of application control trees, and then using these controls in the trees as the basis for generating a few short examples using another CLL. Note that the pre-processing is done only once for each application. The application's application control tree and its few short example dataset are repeatedly used at runtime. In real time, Savant works as follows. When the user gives a command, Savant first selects the relevant few short examples from the previously generated dataset to construct a prompt. So for our previous instance, set the margin to narrow. Savant utilizes word similarity search method to select the relevant few short examples. So for this query, the relevant few short examples are margins. The control element is margin, the value is narrow, and the query is change the margin to narrow. Similarly, the second top candidate would be margins, normal, change the margins to normal. So these examples will be used as in-context application-specific few short guiding examples in the prompt. So this prompt is then fed to large language model to determine the control element on which the specified action needs to be performed. Savant then locates the control element in the actual application control tree and fabricates a plan to execute the intended action on the control. As the specified control element may not be initially visible on the application's GUI, a sequence of actions on the control elements may have to be performed first to make the target control element visible. So once the target control element is visible, the user specified action is finally executed by Savant. So let's see how Savant automates the sequence of screen reader steps in response to a natural language query. So for the query, set the margin to narrow, Savant first identifies the equivalent GUI path from the application control tree. For this query, the path would be menu ribbon, layout, margins, narrow. Next, using this path, it starts simulating the clicks on the actual application tree, the UI, the automation tree of that application. So here, it first selects the menu ribbon, and then it selects the layout tab. Once the layout tab controls are visible, it selects the margin control element in the layout tab. Once the drop-down menu options of the margin controls are visible, it selects the narrow control element and it gives the feedback to the user that the task was successfully completed. We assessed Gen LLM's performance using the Wizard of a Study dataset, where it achieved a 78% accuracy, successfully processing 113 out of 145 commands. Most errors came from commands with multiple instructions or composite tasks like copy and paste, which pose challenges. This highlights the LLM's limitations in handling multi-step commands. So we are now focusing on improving its ability to manage these complex combined actions for more seamless task processing in the future. So we conducted an IRB approach study with 11 blind screen reader users. The inclusion criteria required the participants to be proficient in using the JAWS screen reader and be familiar with the Windows operating system. In a within subject experimental setup, the participants were ask it to do representative tasks shown in the bottom table under three conditions to compare with Savant with default screen reader and a state-of-the-art solution. In the study, Savant significantly outperformed the other two baseline conditions in task completion rate, average task completion time, and average number of key presses per task, as shown in the slide. Specifically, Savant achieved a task completion rate of 81.81%, completing 18 out of 22 tasks. The average time spent per task was reduced to 101 seconds, and the total number of key presses was comparatively lower, requiring only 44 keystrokes. The responses to subjective questionnaires were significantly in favor of Savant when juxtaposed with the other study conditions. Users expressed high satisfaction, affirmed their preference for voice-driven interaction, and suggested including additional support for complex cross-application commands and keyboard-free Savant activation using a wake word. The current Savant prototype also has its limitations. So Savant currently does not support access to controls in pop-ups and sub-windows. It cannot automate tasks that require actions in multiple applications. It only accepts commands in English, and it requires pressing a special shortcut for activation. So we will address these limitations in our future work. So this concludes my presentation, and I thank you for your patience and time. Please refer to our full paper for more details by scanning the QR code. If anybody has any questions, I'm happy to answer them.
Thank you very much, Satiq, for a really, really interesting presentation. So I can see that we have some questions in the room, but I do ask Zoom first if there is any questions. If not, yeah, we have a question from the room, please.
Hi, this is Kenny. Thanks for the really cool presentation. I have a friend who has pretty severe mobility impairments in her wrist that makes it very hard occasionally to type or to use a computer. And it seems like it'd be very useful for people kind of who have a similar use case. I'm wondering, I have two questions. The first is, have you looked into how this might be adapted to people with mobility impairments? And question two is, it seems like, you mentioned the crawler will kind of look for the actionable items. And I'm wondering, are there any fallbacks for maybe if it's unable to find the right sequence of steps?
Yeah. So we are working on making accessible to all the users. So we are working on to improve its ability to make sure that it can be accessible by all the users. And answering the second question, there are many instances in our user study where it couldn't find the correct sequence of action because right now our Savant interface supports only application controls that are visible and invisible up to some extent. As I mentioned, the pop-up windows and sub-windows are not currently being handled. So in many instances, when user gave the natural language commands that involved multiple applications or sub-windows, LLM couldn't or a crawler couldn't identify the correct sequence of actions in those scenarios.
So in those scenarios, did you have to step in as a researcher to kind of make those actions happen?
Yes, so in that case, we had to restart our system and users has to reissue the command to continue working and so on.
That's really interesting. Thanks so much.
Thank you.
We do have time for one more question, particularly because it comes from one of the organizers, otherwise they'll wrap up everything and we have to leave. Please.
Sounds like a threat. Wow. My name is David Flala. Very nice work. There's something about what you're doing here that makes me think everybody in the world would want this. But when you take a technology specifically for an audience with disabilities and generalize it to everyone, sometimes that initial population gets chucked, they get forgotten, because there's a bigger market for everyone else. Can you speculate a little bit on some of the risks that might involve if this becomes a firestorm and everybody wants it? Question mark.
Okay, so like since our application does not require any kind of keyboard shortcuts to interact, with just natural language query, like they just have to issue a natural language query to work with. So we hope that this will be very useful for all kinds of disability, regardless whether they are blind or any kind of disability. And so we hope that we want to aim that this application is specifically designed for blind users first. So it has to be more accessible for blind users first. Later, we target this to open source and make it accessible to all the users.
Okay, thank you very much.
Yeah.
All right, thank you very much. So please give Sadiq a big round of applause. Thank you so much.